This video is going to go through our lesson on regression. So what we're going to take a look at to start is what a scatter plot looks like. And what a scatter plot is displaying is it's a graphical display of two related sets of data. So this can indicate if there's a pattern or some kind of trend in the relationship between the two variables. In this case, the scatter plot is representing some relationship we're seeing between weight versus height. In our current unit, we are studying exponential functions. So to have a regression model that would represent an exponential relationship would be our ability to type data in and see an equation, an exponential equation that could best fit that data that we're being given. So anytime data grows or maybe decays as a percentage of increase or decrease, oftentimes these problems deal with the growth of population or bacteria. Sometimes decay talks about a radioactive substance that's decaying over time. And then again, the shape of an exponential, which we've looked at this unit, sometimes looks like a J when it's exponential growth, or if we saw, maybe some model that represented exponential decay, it might look something more like this, where it's starting at a larger value and then getting smaller and smaller over time. The other type of regression model that would be appropriate to look at in this unit, because it's a function that we've studied, would be power regression models. Power regression comes from polynomial. So anytime x is being raised to a power. So if let's say scatter plot has more of a quadratic look where the values go down, they hit some minimum and then come back up. Or maybe cubic, they hit a max, then they start to decrease again, hit a min, then they increase again. So this would be told to you in the problem that you're trying to calculate either an exponential or power regression model, and then we're going to show you how to apply that in the problems given. So for question number 1, what I'd like you to do is first just take a moment to read it. So this data, this scatter plot, is representing the price of a postage stamp in the years since the end of World War I. So it's giving us years since the end of World War I on our x-axis and the price in cents on our y-axis. And if I just kind of look at the shape of this, again, trying to maybe connect these points, but not really because they're not in a perfect exponential shape, but they look pretty exponential if you look at it overall. And then I look at these choices below. They're trying to have me pick out the best model, the equation that best models the price of this based on these 4 choices. So as I'm looking, exponential would mean that I need to have x in the exponent. So that means choice 1 and choice 4 are no good. Choice 1 is a linear relationship. Choice 4 is trigonometric, which we have not gotten to yet, but hopefully we can at least recognize that choice 4 does not look exponential. So now what I want to do is I want to be able to determine, well, which exponential is appropriate. So I'm going to open up my calculator, hopefully be able to do this without too much of a struggle. Sorry, everybody. Of course, I'm having a technical issue. Okay. So if I bring that up, okay, now I have, I want to type in these 2 functions. So y equals 1.04 times 1.43 to the x, and then the other has a different leading coefficient or leading initial amount, 1.43, and a different base, 1.04 to the x. Okay, I also want to take a moment to adjust my settings. So in this scatter plot, I can see that my x min is 0 and my x max is 100. So I'm going to make it look like that. And then I can see that my y min is negative 10 and my y max is 60. Okay, so I'm going to get rid of that. Now, looking on this display, the red graph versus the blue graph definitely looks more like what I was seeing in my scatter plot. Oh, I guess I can't highlight over that. But the red graph, if I were to see that on my scatter plot, that looks more like that. So the one I typed in, the first choice, is not correct, but the second choice, which really in my multiple choice is choice 3, 1.43 to the times 1.04 to the x power, is the one that best resembles this data. And again, if you went even one step beyond this and opened a table, right, it looks like on this graph there'd be a point somewhere around like 40 comma, I don't know, maybe something in between 0 and 10. So if I typed in like 40 to my table, there's that number between 0 and 10, so about 6.86, and that makes sense for this point here. Whereas if you had compared table values for the first one, again, if maybe the graph wasn't super clear, if I typed in 40 to this graph, it's such a big number that it doesn't even fit in the table. That's scientific notation. That would be a number representative in the millions. Okay. Now, let's take a look at number 2. So I don't want to lose my calculator, which I totally just did. All right, so for number 2, we're going to take a look at this given data. So they told us we have a cup of soup left on a countertop to cool. The time in minutes is represented by X. The temperature in degrees Fahrenheit are my Y values. And I'm being told to write an exponential regression equation for this data. So I'm going to take this. You know what? That's probably a better way of doing it so I don't lose everything. Okay. So the first thing we're going to do is we're going to make our own table. So how do we do that? We're going to kind of clear everything out here in Desmos, and we're going to hit the plus sign that's right above where the number 1 spot to write something in is. And that plus sign gives me a couple options. I'm going to pick table. And now I'm going to type in all of my x's, the 0, the 2, the 4, the 6, 8, and 10. And then we're going to write in all the y's. So just take a minute to do what I'm doing. Type those values into your calculator. Okay, once you get everything typed in, it's always a good idea to double check that you didn't type in anything wrong. All your decimals are correct. All values are typed in accurately. And then you're going to click this button to the left of where X1 is in the table that kind of looks like a scatter plot with a line drawn through it. It's going to automatically try to make this linear because that's the first choice in the table. So you're going to go to this drop-down menu and you're going to find the one that says exponential regression. Now, see this little spot here that says log mode and it's checked? You want to leave that. All that means is that this is going to calculate this regression equation similar to how it would calculate it on the TI-84 or any other like scientific or graphing calculator that is used in like an Algebra 2 class. So you're going to leave that checked, and then I'm going to take these numbers. So I'm just going to write the equation that I see. Y equals 180.37687 times 0.95387 to the x power. And now it's asking me here to round to the nearest thousandth. So just to remember, 1,000 is a number that has 3 zeros. So I need to round 3 places after my decimal. So that means I'm really looking to that 4th place. This is going to round this up to a 7. This is going to round this up to a 4. So my equation that I'm going to have is y equals 180.377. I'm going to put parentheses around my base, times 0.954 to the x. So this is my regression equation that would best resemble the data in this table. Then they go on to say, use this equation. So we're not going to take the equation from our calculator that had like more values. We're going to use the one we just boxed in to estimate to the nearest 10th of a degree the temperature in 1 hour. So time is my x values, time in minutes. So the first thing I need to recognize is that 1 hour really needs to be turned into minutes. So I'm going to multiply that by 60 and just get that there are 60 minutes in an hour. So that's my t value. And they want me to find the temperature. So they're asking me to find y when x, or t in this case, is, oh no, not t, sorry. They are using x, when x is 60. Okay, so I'm going to plug in for x, 180.377 times 0.954 to the 60. So we can come over here, take our equation, and again, we're using the rounded equation. Okay, and to the nearest tenth of a degree, that would be 10.692. So nearest tenth, it would be 10.7 degrees Fahrenheit. You don't have to write the units. You could just write 10.7. Okay, and then we're going to just take a look at one more question. The next question involves information given to us where we're looking at the growth of bacteria over time in minutes. And for this question, we're being asked to write a power regression. So when I go to type my data into my calculator, I just will choose the other choice. So we're going to take all of our x values and we're going to type them into the x column. So 1, 3. It's going to always like try to guess what you're doing. So I actually am going by odd numbers. So it will fill them in for me if I want it to. You could always change it if it's not consistently going by that number, because with regression, it's not always going to be consistent the way they give you the numbers. 310, 497. Once you get these values in, also something that is happening on my graph is it is plotting them. Not that you like need to see that, but you could if you wanted to. I'm going to hit the regression button. I'm going to go down here. I'm going to change it to power, so it's a little further down than where exponential was. Again, we're going to leave that log mode clicked, and I'm going to take a moment. The difference between, excuse me, question 3 and question 2, in question 2, everything was written as x and y. The calculator gives you things in x and y. It's a little bit more what we're used to writing. In this question, they are using different variables. So instead of x, they're using t, and instead of y, they're using b. So even though my calculator and the equation I might write down, which is y equals 2.00088 times x to the power of 2.29806, I really can't leave it like that. I need to make the x into a t, and the y should be a b. And then I also need to make sure I'm rounding correctly. So rounding 3 decimal places. So that means 1, 2, 3. This will round up the 0. 1, 2, 3. This won't round anything. So my final equation should be b is equal to 2.001 times x to the 2.298. Okay, so that's the first part. Just get the data into the calculator, get your regression equation based on the appropriate model asked of you, so in this case, power. And then once you get that, round your values and also check to make sure that you're using the right variables. Then this question has 2 follow-ups for us to answer. So the first one says we're asked to predict the bacteria's growth after 15 minutes. So 15 minutes, that's a t-value. And I'm asked to figure out the b. So this is just a plug-in. So using our equation again, right, it always says that to you, so you don't go back and try to use the one that had like more decimal values. You're using the one that we, oh wait, and I just caught a mistake. I just told you to worry about your variables, and then I wrote a t, wrote an x instead of a t. So make sure you come back to the first part with me here. That should not have been left as an x. That should have been a t. I apologize. Okay, so now I'm replacing that t with a 15 for the second part, 2.298, and we're going to type this in. Okay, and to the nearest integer, that should equal 1009. Okay, and then for the next part, again, using this equation, now algebraically determine how long it would take. So we're looking now for a t for the bacteria population to reach 600. So they're giving us a b, and asking us to find t. So that's always going to involve a little bit of algebra when you're solving for x, which in this case is called t. So I'm going to replace the b with 600, leave the t in my equation, and try to solve for that. Okay, so the first thing I want to recognize is that the 2.001 is connected to my t through multiplication. So I'm going to divide by 2.001. And then it's always a good idea not to round, but if I go over here and I just want to have like an approximation of that, 2.001, I get about 299.85. I'm going to write ... So I'm going to keep the full number in my calculator to use in my next step, but I won't write like the whole thing here. And then what I'm going to do is take a root of both sides, but my root should have 2.298 in the index. So I'm taking the 2.298 root. So I'm going to go to my calculator. I'm going to go to functions all the way to the bottom, get my nth root key, type in 2.298 inside here, and then you should be able to copy. You could probably do it on your Chromebook better than I can. I'm going to type this whole number in, 299.85007. And then from that, you end up with 11.9633 ... And they said, determine how long it would take. So we'll say to the nearest, it doesn't really say. So to the nearest minute, we'll say 12 minutes. And again, if you don't write the minutes, you would not lose credit. You just need to have the number 12 there. Okay, so please take some time to look over the video. If you go on to the practice questions, you'll notice at the end of the practice, the answers are there for you to check. And if you go on to Canvas, our full worked out key of the practice questions are there as well. So feel free to jump on Canvas as you work through the practice and check there to see how you're doing. Thanks, everybody.